And this feature showcase will use a sample application written in Python Flask. This application has two tiers. First one is the UI one, the UI part, which is just JavaScript based application, and it reaches out into Kubernetes, which load balances the requests across more than one instances of the backend. The backend will respond with an HTML fragment that the front end will then render into the browser. Alright, so here is that application. I'm going to run it using Flask, and it's listening on port 5000 now. Just adjust this, and then we'll go to localhost 5000, and here's that application, and we can see that it's reaching out to the backend, getting slash data. Right? We don't have any of this information for now, but we'll get that once it's deployed to Kubernetes, right? Because this is Kubernetes related information. Now, in order for us to deploy this application into Kubernetes, we don't have to tell Kubernetes every step that it needs to do to be able to deploy the application. Rather, we're going to declaratively deploy the application. And by declaratively, I say we tell Kubernetes what our desired end state is, and Kubernetes will take care of doing whatever it needs to do to get to that end state, right? We don't care about the intermediate states. We just care about the end states. As a quick run through of how that looks like, in the real world, here is a sample deployment file that you feed into Kubernetes so that it'll know how to deploy your microservice, right? And this is just ordinary YAML, really. And the first, I'm just going to highlight a few parts here. There are there's a lot of options that's available to you with this simple file, but I'm just going to highlight a few of them right now. So the first part over here is the first line API version. You tell Kubernetes, I'm going to use app/v1 of the deployment object, right? So Kubernetes versions not only its API endpoints, but also the YAML files, the schema of the YAML files that you're going to feed it, right? And for this file, we're saying, this is a deployment. And further down, we tell Kubernetes we want 3 replicas of our microservice, right? And further down, we tell Kubernetes where to get the container or the container image that will be used to instantiate your microservice, right? So again, it's a very simple concept, declarative deployment, where you only need to specify the end goal and not have to worry about the intermediate steps to get there, right? It's a very simple concept, but it's very powerful because it enables you to do a lot of complex deployment strategies, which we'll see in a bit. All right, so here we are back at our terminal. We're going to show how to deploy our sample application into Kubernetes. And first of all, here is the same manifest file, but with more details this time. You'll see that apps v1 and then kind deployment is there. You'll see that we specified replicas there, 3 replicas, and then you also see here the container image, right? Which is a little bit different from the one in the slide, but essentially does the same thing, right? And there's a bunch of other stuff in this deployment file, but don't worry, we'll get to those parts later in the course. Right. For now, we're going to quit that one, and just to show that there's nothing running behind our sample application, we're going to open up the domain name or the host name of our sample app and see that there's nothing there, right? It's just a Kubernetes default backend responding with a 404 saying the application is not yet deployed. And so for now, we're going to do kubectl get pods. All right, so we can see that in the browser, there's no instance of our application yet because Kubernetes is reporting that there's no application in that address as of right now. And also at the top of our terminal here, we can see that there are no pods deployed into our Kubernetes environment. So let's go ahead and deploy our application, our sample app, by typing in kubectl and then create, and then pointing kubectl to our v1 manifest, the one that I showed just a few seconds back, right? And there you have it. It's now saying, creating the application. We now have one running instance, and one of the instances is ready. So if we go ahead and refresh this, then we can see our application is running there. And we currently have all three are reporting, right? So this is version 1 sample app. You'll see that the pod name matches the pod names that we have listed here. Each pod has an IP, a cluster IP on its own, and then whether this is publicly accessible or not, it's something that it's configurable. But this is just an IP that's accessible within the cluster, right? And we can see which node a particular pod is located in, and we're also keeping track of how many times the pod has been hit by the browser, right? It's always counting up. And so that's declarative deployment through Kubernetes, which is a single command. All right, so now we have version 1 of our microservice, and we have 3 replicas of version 1. But what if now we want to deploy version 2? Well, it's a very simple, just a single command for that we issue to Kubernetes, and it'll be capable of, or it will do a rolling update. And by rolling update, I mean it'll create an instance of v2, kill one instance of version 1, and then move to the next instance, and so on and so forth, right? So that's rolling update. And we'll see this in action with just a single command. All right, so we're back to our sample application here. And to show you the rolling update, I have a simple script here, rolling update. Right. And the script, all it does really is just, it runs kubectl apply, and then point to, version 2 of the manifest. Actually, you know what? Let's not even run that script. Let's just do, let's do it here via the terminal directly. Kubectl apply -f manifests v2. Yeah, right? And we'll see how it'll Kubernetes will create new pods and then kill another one, and then we'll also see how with each refresh, some parts turn green, and shift between green and blue, right? It's just the same color as our the one that we showed in the slides earlier, right? And then finally it'll be just all green. So let's do it. So now it's creating a new instance, right? Terminating an existing one, and you'll see how it's shifting from blue to green as Kubernetes is creating version 2 and terminating version 1, right? Until finally we get to a point where it's going to be all green. Right now we still have one, and that'll be terminated shortly. There it is, being terminated. And since, that's all gone, and now everything is green. Up next is blue-green deployment. Blue-green deployment allows you to stage your latest version of your microservice without fully committing to it until you're 100% sure that this latest version is worthy of production. So we're going to implement blue-green deployment for our sample application by first creating the version 2 instances, of our microservice, and then observing if version 2 is behaving as expected, and only then do we direct all future requests to version 2 before killing off version 1. Alright, so let's try the blue-green deployment strategy this time. I'm going to show you a script here called blue-green sh, right? And all it does is really it just executes 3 kubectl commands. The first one is that it deploys it stages version 2 or the green deployment, and after sending this to Kubernetes, it then tracks the status of that green environment, whether it's fully rolled out or not, right? So this will keep this will loop until Kubernetes is done. This will loop and check with Kubernetes if version 2 is done deploying before it returns to the terminal, right? And then finally we have here a third command, just kubectl apply, which modifies the load balancer such that it redirects all requests to the green environment. All right. It's written as script so that I don't forget the different steps, but really there's not a lot of logic here. In fact, there's not any logic here because all we're doing is just issuing commands blindly, and all of the business logic with regards to blue-green deployment is already on the Kubernetes side. Right. So here we go. We're gonna do blue-green scripts, if I can type correctly, blue-green, right? So it's staging sample app v2, and you'll see that the v2 containers or the v2 pods are being created, and we're checking the rollout status, and now Kubernetes reports back that sample app v2 has been successfully rolled out, but we haven't switched the load balancer to point to the v2 instances yet, and that's why you still see blue, the blue version or version 1 over here. And when I hit enter here, it's going to issue that last kubectl command, which is to modify the load balancer such that it directs all of the requests to v2, right? So let's do that. And you see all requests are now being served by v2. All the responses are in green, right? And that's blue-green deployment, right? With just 3 simple commands. And here's another deployment strategy that you're able to do with Kubernetes very powerful declarative deployment. So canary deployment is when you want to try out the latest version of your application, but you don't want to spend a lot of resources for it. You just want to try it out, not for all requests, but a portion of the requests coming in, and then observing that before fully committing to it, right? So you do that by creating a canary instance, redirecting some of the requests there, right? And then when you're happy with it, you then fully commit to that and then terminate your old version. Alright, so here we are back in our sample application, and to demo the canary deployment strategy, I'm going to show you a canary script that I have here, and this time it just executes 4 kubectl commands, right? So the first one, kubectl apply manifest, it'll just apply the canary deployment for v2, right? And this, all it does is it'll instantiate 1 instance of v2. And over here we're just checking if the canary has been fully rolled out, right? Or at least the initial canary has been rolled out, and then it'll wait for us to switch to the green deployment. And as soon as we hit enter here, v2 will be scaled up to 3 replicas, and v1 will be scaled down to 0 replicas, effectively replacing v1 with v2, right? All right, so let's try that out. So scripts canary, right? And we'll see a new pod being created here, right? And then the canary, as soon as it's ready, it'll start serving requests, some of the requests, right? alongside our 3 version 1s, and you'll see version 2 will show up here, and then goes back to version 1, right? So the load balancer is sending some of the traffic to version 2, right? And this allows us to test whether version 2 is behaving correctly or not, and if it doesn't behave correctly, we'll see it in our monitoring consoles, right? And then we can back off very quickly, right? But let's say version 2, we're happy with it, it's performing fine. Let's now fully commit to the green deployment, right? So we'll hit enter there, and then V2 is now being scaled up and V1 is being scaled down. There we go. So, and finally we have the third one, right? It's all green now, and that's canary deployment. Now, here's another feature that comes built into Kubernetes. In our deployment, since we specified that we want 3 instances all the time, right? And because pods can, die at any time, Kubernetes comes with an auto-healing feature whereby if one of your pods die, Kubernetes will then detect that the current number of instances is 1 below the desired number of instances. So it'll automatically create a new instance of your microservice, and you are back to having 3 replicas. And should there be any persistent volumes that were attached to pod number 3, right, Kubernetes can then automatically reattach that to pod number 4, right, thereby allowing you to keep the state of your application. Alright, so we're back with our sample application, and what I'm going to do to demonstrate auto healing is to just go ahead and delete one of the pods here, right? Remember, we've already told through our deployment that manifest that we want 3 instances all the time of our sample application. Now if I go ahead and manually delete pod, that certain pod, Kubernetes will detect it and then immediately create a replacement for that, right? So there you go, BS9 VF is gone, CZ is taking over its place, right? And you'll see how CZ has just a couple of hits, while all the rest have 100 hits already, right? We can keep doing this all day, and Kubernetes won't complain. It'll happily just replace any dead pods. All right. Now, pod auto healing is not limited to a pod dying, right? Kubernetes is also capable of auto healing pods when the node that hosts the pod, right? It could be a VM, it could be a bare metal, right? If one of those nodes die, then Kubernetes is able to heal that. Like, let's say, for example, node number 2 that's hosting pod number 2 died. So Kubernetes will then detect that and then automatically schedule, perhaps in node number 3, a replacement pod, allowing you to keep the availability of your application at the desired level. Now that's it for the feature showcase for Kubernetes. Now what I've shown you is just it's a very small portion of what Kubernetes can do, but and we'll get a chance to experience those different features and go through get our hands dirty with those different features later on in the course module. For now, I want to refocus your attention to the community behind Kubernetes. Now, Kubernetes was created by Google from their more than 10 years of learnings in building their original microservice orchestration layer, Borg, right? Now, ever since then, Google has handed off management of the Kubernetes project to the Cloud Native Computing Foundation. Cloud Native Computing Foundation is the cloud native arm of the Linux Foundation, right? They are sister foundations, and the Cloud Native Computing Foundation members are currently they number in the hundreds. So platinum members, first of all, is AWS, Cisco, Alibaba Cloud, Dell, Docker, Fujitsu, and so on, right? And then further down we have gold members, which is quite a long list. And even further down, we will see end user members, right? You'll see a number of those are quite well known. And even further down, we have academic or nonprofit members. So the Cloud Native Computing Foundation is very, very much alive and healthy. And because the Cloud Native Computing Foundation's poster project is Kubernetes, then it follows that Kubernetes has a very strong backing behind it. Here's another perspective of the community. This is from the DevStats website maintained by the Cloud Native Computing Foundation, and this lists the company contributions metric for Kubernetes alone. Right, we're not even talking about all of the projects that are being managed by CNCF. We're just talking about Kubernetes here. As expected, Google is number one because they started Kubernetes, and then Red Hat also it comes in second because of their OpenShift work, where starting with OpenShift 3 they used Kubernetes at its core, and then we have Microsoft, a lot of independent contributors, which it's a good sign, and so on and so forth. I'm gonna add some high-profile users here: eBay, AT&T, probably just screenshots of headlines showing how the big companies, serious companies, are really believe in the the Kubernetes project. And then finally, I'm going to talk about the CNCF trail map, where we will cover the various steps that an organization needs to take as it goes through its journey of adopting cloud native computing into their workplace, right? And we're going to highlight some of the stuff that we'll be covering in KA 101 as well. So starting with Kubernetes, and then maybe FluentD and Prometheus, probably Envoy, or maybe Core DNS. CNI, gRPC is also covered there, right? Taken for granted, but we're not going to get our hands dirty on this one. But we can just say, yeah, gRPC is used underneath. But yeah, that is it for this very quick walkthrough of